on purpose. Good try, though. Okay, so x minus 7. If we do that, what that means is we're going to start our absolute value function down 7. So we're going to move it down 7 units. So 1, 2, 3, 4, 5, 6, 7. And then it is just going to be a 45-degree angle all the way back up. So it's going to look the exact same. It's just down 7 units. So if there is a subtraction outside the absolute value function, that means up and down. So addition plus 7 would mean that you went up 7 units and then drew it. Make sense?
So are you just freehanding me, little B?
No. I mean, you are, but I'm not. Like,
yeah, that's what.
So, if we go for horizontal translations, we can also move left to right. And that is going to be if we have something on the inside of the absolute value. So if we have x minus 2, then that means we are going to move right. So normally minus means you're going to move left, but if it is inside the absolute value function like this, it means you move left. So you move the opposite direction of what you expect. So when we draw this, if we do our regular graph, then that means we are going to move right 2 units and our central point will be right here. So it will look just like that. So pretty simple on translations up and down.
Wait, I'll miss that.
Okay, so if we plug in, or if we have something that looks like this, the absolute value of x minus 2 on the inside of the absolute value function. This is the absolute value part. Those are the absolute value bars. So when we graph that, you take this sign and you move the other way of what you expect, because usually negative is left. So if it's on the inside, you're moving the other way. So we're moving right for 2 steps. So we go 1, 2, and then we draw a regular V. We have sometimes we'll have something that combines these two. So maybe I'll be able to move. There we go. The absolute value of x plus 2 minus 4. So if we do this, we look for how we're going to move it. So I like to write on the side how far I'm going to move it in each direction. So R or L, right or left, U or D. So this is going to tell me right or left. It's on the outside of the absolute value function. I'm sorry, that's wrong. This is going to tell me up and down because it's on the outside of the absolute value function. This is going to tell me right or left because it's on the inside. So here we go how we expect. So we're going down 4. And here we go the opposite way of what we expect. So instead of going to the right, we're going to the left 2. So left 2. So I'm going to go left 2, down 4. I'm going to put my dot, and I'm going to draw my 45-degree angles. This 45-degree angle thing is going to be a pattern for a while. It will change coming up, but general absolute value function is 45-degree angle. Does it make sense how we're doing the translations up and down, left and right? Vaguely? Okay. Sometimes we're going to have a negative absolute value, and all that means is we're going to flip it. So we're going to turn it upside down. So instead of it going up and down at a 45-degree angle, it is going to go down at a 45-degree angle. So it's going to look like this. So we erase these because that is the positive part. This is the negative part. Sorry, I erased that. So a negative makes it flip up and down. And I do have a little cheat sheet that's going to help you with this. So I'll send it out to you guys when this is over. And I'll show it to you in just a minute so you can write it down. So another thing that it likes to ask is the vertex or the opens or the maximum or minimum. And all it's asking is, so the vertex is like right here. It's like the central point. So as long as you can identify this point, in this case, it's really easy. It's just 0, 0. And when it asks opens, this opens down because, it opens down. I feel like that's pretty self-explanatory. And then if we're looking for maximum or minimum, we are looking for, this is going to be the maximum point of the graph. It's as high as it will go. Whereas if it's the other way, if it looks like this, then this is the minimum point of the graph. So it's just if the vertex is on top or on bottom. If it's on top, maximum. If it's on bottom, minimum. And describe the translation is exactly what I did right here. So left 2, down 4 is exactly the description of the translation. That's another thing that it will ask you. I'm trying to go through the access stuff. Most of it looks like this. So, I mean, if you have like a negative x minus 2 in the absolute value bars, I'm going to make them dark just to make it clear. Minus 3. Give that a shot. See if you can graph it, and then I'll walk through it. Yes, you guys graph it. You got paper? Let me work it. Okay, so time to work it. I haven't worked it yet. Okay, so the first thing that I see is on the inside here, we have a negative 2, which means that I will move right 2. So I'm going to move right 2. Here, I see that I'm moving down 3. So 1, 2, 3. So this would be my vertex, which would be 2, -3.
I don't see your screen. Oh, no, I just see dots. All right, that's it.
Well, it went away.
Full screen.
Yeah, there we go. Okay, so the other thing that I see is that we have a negative out front. And the negative out front is going to make it go down instead of up. So it's going to look like this. So that's the actual graph of it. This is a maximum value because it's on top. The vertex is at 2, -3. And what else does it want to know?
So is it in that bottom quadrant because it's negative?
No, it's in that bottom quadrant because we have these translations up here. So the translation, the -3 on the outside right here makes it move down 3. And then this -2 here makes it move right 2.
So if it was positive, it would be up.
If this is the part that makes it go down, this negative on the outside here. So one other thing that you will need to know that will affect what your graph will look like is stretching and shrinking. So if we have something that is multiplied by our absolute value, so we have 2 times the absolute value of x. So that is going to stretch our graph out. So it's going to make it wider. If we have something greater than 1, so anything that will make the number bigger, it's going to stretch it. And this is going to stretch it by a factor of 2. I don't know what that means to actually draw. Desmos or whatever will be able to draw it, but it's going to get wider. So I just draw it wider.
That's why I figured out on absolute value.
That's why I don't want to be used.
Symbolab is another good graphing tool. So just knowing that multiplying here, something multiplied by your absolute value means that it stretches. If this number is less than 1, meaning it's a fraction or a decimal, 1/2, that means that it is going to shrink. So that might be what your graph looks like. If it's negative, this might be what your graph looks like. Just facing down. All your regular rules still apply. It just goes,
So if they ask you to graph that, that's what you're going to do?
no, if they ask you to graph what's up there right now, that's what you're going to put. So it looks like that. If maybe you have x minus 2, or we'll do x plus 2 here, minus 3. So we can still do this. We do our +2 translation, which I believe takes us left 2 units. So we go 1, 2, and then 3. So that's down 3. So 1, 2, 3. Put the dot here. We see that it's negative, and we see that it shrunk by 1/2. So we shrink it, and we face it down. Absolutely. Is that good enough? So this is just about as complicated as it's going to get for these type of problems. The little cheat sheet that I have here is, well, if I could get it to show up.
So you don't do those other lines when you're shrinking, because you have put other lines between your.
No, the other lines were just me, like when I was changing the graph every time. That's what the other lines would look like. So this is what it looks like for the absolute value function in its translations. So if your regular function is y equals absolute value of x, then these tell you what it is. So if you have a number on the outside right here, then it's going to go up. If you have a number subtracted on the outside, it's going to go down. So same thing with horizontal, all of the above, and then shrinking and stretching. So this is just useful for remembering what goes where and which way everything goes. I'll send it out later, but you can Google it, like absolute value function translation cheat sheet. I know that's a mouthful, but this is what you will get. Okay, so questions on absolute value functions. You guys feel okay? Good enough for me to move on? Okay, moving on. Let me pull the homework back up. And we will go to
You do like a hard problem.
a hard problem. Yeah. Okay, so do what?
Number 8
What is number 8?
or 9.
Give me number 9.
3x plus 6 equals. It got the little bar thing. No, we're 107, aren't we? 107.
107 is graphing absolute value functions.
Oh, sorry, I was on 107.
I haven't got to 107 yet.
Oh, never mind.
We were on 106.
Oh, 107 is similar.
Am I wrong? No, we were on 107 right then. I'm sorry.
Oh,
Okay, so what is this number that you want me to work? Well, I don't have it pulled up, so if you could read me the problem, I would appreciate it.
Okay, I'll write it down because I'm not going to say it right.
I'll try to find it.
It's the absolute value of 3x plus 6 equals the absolute value of negative 9x minus 12.
Well, I already wrote it down.
So this, and then what's on the other side?
Absolute value of negative 9x minus 12.
Okay, and what does it want us to know? Is it like that?
Copy and paste your picture.
That's just exactly what it is.
Okay. So let's take a look and see if we can get Desmos to graph this.
Yeah, that'd be easier, you know?
It would.
Or we could get Sigma Lab. I already got it favored.
All right, let me copy and paste this and we will go test it out.
They don't let you copy.
Mm. Oh.
I was asleep. I was resting my eyes.
Well, you're the small.
And then you every time you feel like
Before we took it, must have.
that's an absolute thing.
So that is what that looks like. But also, I don't think it wants us to know that. It wants
It says answer.
use GeoGebra linked on the task page to solve the next 3 problems. So all you need to do is plug these problems in and it will give you the answer.
Are you sure?
I mean, that's what I'm looking at. It asks you to use a graphing tool.
Let's do
Okay. This is number 9. You can copy and paste it. I just did. Let's try it on GeoGebra.
I thought you were trying to say algebra, but just pronounced it wrong.
I wish.
We got here at 9:30, right?
Mhm. Okay, so the first part of this is,
Is it negative 7?
so you graph these and what you're looking for are crosses.
Mom, wait, how do you do that?
It keeps deleting and,
What do you mean?
Where do we?
So, I mean, I went to GeoGebra and I typed in the problem.
Hold on. I don't see the little straight, I don't see the straight line.
What's that, mine says a straight line.
Are y'all
Mine
putting,
has a V, and it keeps deleting.
No, I don't see the straight line in the graph.
Mine put a straight line.
okay, let me come over there and look at what you
Oh,
guys
it's a
have.
straight line by itself there.
No,
They didn't put it in.
Oh, you copy and paste, that's what I'm
oh,
doing.
that's why I don't copy and
Okay,
paste
you
it.
can,
But they put it in.
You ain't even doing it. That's
Shut up,
it,
that's
I
what you
copy and
do.
paste it and put two straight lines up.
okay, put one of them on the top one. Like, you can type ABS.
Perhaps.
ABS is a shortcut for absolute value in a lot of cases. You can just type in 2 or 3
Wait,
plus 6.
Mr. Albright,
Okay.
Like, couldn't
look,
All right,
okay.
now click on the bottom one. Now type in the second part.
Okay, no.
Oh, it says 21.
Lord, I don't know what I'm doing
Is this
You're good.
right?
Go here.
Well, mine say 21.
Nope.
That's all right.
You got 2 points.
yet. You know what you do? Stop saying no.
Only
If
got
this would go away.
1.
It's 21, right?
No.
We want, yes, click it, now go expression.
How did you get that?
There are 2 answers.
Mine isn't.
So you got that. 21.
No, it did that itself.
Okay, so
Because
right
9
here,
plus 10 is 21.
okay, you have this. Where did you
No,
get
it's
it?
not. 9 plus 10, 20.
Oh.
X.
But you go 9 plus 10 is 20? Oh, how do you?
9 plus 10 is 19.
It's 21.
I still
Why
don't.
Why you just said it's
You
21?
dumb.
Or
She just said it's 21.
just regular.
Duh, Alex.
Yes.
I'm 9 plus, they just said 9 plus 10, 19.
It's 21.
It's 21.
Okay,
Look, it's still in there. This why I'm this why I be failing.
You should
Now
just
watch,
write-
I put an X.
Oh, it's not.
Put it right there in front of it. And it's
Is it for real?
Alex, you so what is that? What is that? I need to delete it. Is it too late to drop?
yes, it's too late to drop it off.
It's not, who's back in the grade, where did just kick me out? Who's that?
What is it? Negative 9x minus 12.
Yes.
Okay, now
Boom, still the same. Put that down.
put it in.
Boom, got it.
Why ain't God?
Thank you. I did this on my
Come
own.
here.
Hang on,
Oh, okay.
I'm working on it.
Oh, they got a D.
Wrongly.
Negative 9x minus 12
Yes, you do.
and 1.
I got a
That's
whole
what
pack
you're
of
looking
them
for,
at the
I think.
house.
But bring one, bring some.
We got a whole job.
Absolute
Right, you
value.
can
What's
make
the
it
first
big,
one?
right?
Who?
The 3X.
Like I said, bring is that.
Plus.
But I bring you some.
Alright,
No,
that should be.
I gotta go to
Now you're
college
looking
next
for
semester.
places that they
I
cross.
can't be spending money like that.
You good?
No, if you get in.
ABS.
Stop playing with me. Definitely.
3x plus
I know you ain't,
6.
bro. You got big money.
So,
Did you push enter?
Yes. And ABS is just a shortcut for absolute value.
Why you never told us that?
It's
Now
really,
we're
oh,
looking
look
for
at
speed. Negative 9x minus 12. That's what you want.
That's wrong equation.
Voila.
Okay. So now that we've troubleshot all these issues, we are looking for places that these cross. And one of the reasons that I like Symbolab is because it tells you that. On here, you got to kind of explore a little bit and figure it out. So if we look on here, we're looking for like this dot and this dot. But if we go back to Symbolab and we just copy and paste the problem in, and it tells us right here, x equals negative 3/2 or x equals negative 1. So those would be your two answers for that. Okay, so same thing with this one. If we do 4x minus or 4x plus 4, we could plug that in to GeoGebra. And it's just going to give us another graph. So the key to these is finding where they cross.
Can we use the other website, the one you using?
That's fine.
Symbolab.
You may not be able to get the graph off of Symbolab. It may be, you may need to get the graph off of Desmos or GeoGebra, and then the answer off of Symbolab. Okay, so moving on. We need okay, writing equations of lines. Equations of lines.
No, 8 like it's gonna be easy.
Slope-intercept form.
I like slow.
That lady that put
Oh, that's easy.
grades in for me, I'm pretty sure that was easy.
Wow, yo, I actually over there trying to tell me I was wrong yesterday. I was right.
Okay, so looking at this, we need to write equations of lines. And equations of lines are helpful for being able to draw things just based on looking at one equation instead of having a bunch of different points. So usually how we're going to look at these is y equals mx plus b. Your m is going to be your slope, and your b is going to be your y-intercept, which is where it crosses the y-axis. So, for example, if we have y equals 6x plus 3, then we're going to count up 3, 1, 2, 3, and we're going to put a dot because that is our y-intercept. That is our b. And then from that point on, we are going to use our slope to graph another point. And our slope is usually written as a fraction. So in this case, it's 6, but 6 is the same as 6 over 1, because if you divide anything by 1, it's going to be the same thing. So 6 over 1 is our rise over our run. So we're going to rise 6, 1, 2, 3, 4, 5, 6 over 1. So I put the dot here, and then we do a line through the 2 points. And we are golden. That is what we have. So if we have a if it tells us, okay, our slope is 2 and our y-intercept is 3 and our x-intercept is 2. We can write an equation for this. We actually don't even need the x-intercept part. That's just extra information that they may give you. So what we need is a slope and a y-intercept. And once we have a slope and a y-intercept, we can plug it directly into y equals mx plus b. So our slope goes here for m, and our y-intercept goes here. So m is slope, y-intercept is 3. So we can go back and forth between these two without any troubles. Okay, so there are a couple more things that you're going to need to know to be able to do this. So I encourage you to write. These will be important things that you will need to know. First of which is point slope form. I'm just going to list a bunch of stuff. You guys write it down and then we'll talk about it. Point slope form is y minus y1 equals mx minus x1. The slope formula is y2 minus y1 over x2 minus x1. And then our slope intercept form, like we've already talked about, is y equals mx plus b. Standard form is ax plus by equals c. And I know that's a lot of information, but we are going to use all of it in different situations. We're going to use it all to get the information that we need. So usually they're going to want your answers in either slope intercept or standard form. They're usually not going to ask for it in point slope form. Point slope form is going to be useful for getting things when you have a point and a slope. You can plug it directly into point slope form. When you don't have a slope, the slope formula is useful for getting it. So we're going to jump to one of the more difficult problems on this homework, and we're going to work through it, and we're going to use each of these things. And that will be number 4. If you can do number 4, you can do pretty much anything on this homework sheet. So number 4 is write the equation of the line that passes through these 2 points. And okay, so we need some things to be able to just go ahead and put it in slope intercept form. We need a slope and we need an intercept. We don't have either of those. To put it in point slope form, we need a point and a slope. Well, we don't have a slope, but we do have a point. Well, we can get the slope using the slope formula. So I'm just kind of going through the things that I might need to get it into a form, and I'm looking for information that I can pick out. So with the slope formula, we have y2 minus y1 equals or over x2 minus x1. And the way that I like to do this is -2, -4. I like to make a little chart like this, x, y, 1, 2. So that way I don't get confused as to where my x1 is and where my y2 or whatever. I can just follow the chart. Yes, this is number 4.
There's no negative on mine. It's just 2 positives.
1.08. I'm looking at it right now. This is number 4, I promise.
I was just saying, I said, maybe it's just my computer.
You got on the
I'm gonna
Google
change
Docs.
it to something.
Go to the Google Docs.
Okay, so going from here, we're going to plug this into slope formula. So we find y2, -4 minus, because that comes straight from the formula up here, y1, -6, over -2 minus 2, x2 minus x1. So when we simplify this down, our two negatives make a positive, so we end up with -4 plus 6 over -2 minus 2, so -4. When we work up here, we're going to get a +2 over -4. So that's going to give us a -1/2. So over here with the information that we know, I'm just going to put m equals -1/2, because now that's the information that we can use. So everybody follow me so far? Pretty much. So we found the slope so far. Now we need to go and we need to put this in slope-intercept form. Well, we still don't have an intercept. So this is where point-slope form comes in. We have a point, either one of these, it doesn't matter which one, you can pick one, and we have a slope. So we can now use point-slope form. And down here, I'm going to write point-slope form again. Y minus y1 equals mx minus x1. So now we have our m and we have a point. So I'm going to pick this bottom point. It doesn't matter which one you pick. It's going to come out the same either way. -2, -4. This is our x, this is our y. Well, this is our x1 and our y1. So when we plug in, we're going to get y minus -4 equals -1/2, our slope up here, times x minus -2. So simplifying these signs down, y plus 4 equals -1/2 x plus 2. Again, simplifying, we're going to leave this. Y plus 4 equals -1/2 x plus, minus 1. If you multiply with your calculator, -1/2 times 2, you are going to get -1. So now our goal is, now we look at what it wants it in. And this one wants it in slope-intercept form. And the key to getting something in slope-intercept form is get y by itself. If you're looking for slope-intercept form, y by itself. If you're looking for standard form, x and y are on the same side. So it wants this in slope-intercept form. So all we have to do to get y by itself is subtract this 4. So this is going to cancel. We're going to end up with y over here, -1/2 x minus 5. And this will be our answer for number 4. And if you wanted to, you could take this and you could actually graph it, and it would pass through these points. It would go through both of them. And we found that just by using our slope with our slope formula and our plugging into point slope form. Point slope form is usually a good place to start when you have a point and a slope. If you have an intercept and a slope, then you can go directly into slope-intercept form. There's a bunch of different ways that you can do these problems, and it's up to you guys how you want to approach it. Some extra little information that you might need to know. Parallel means the same slope. So if it asks for a line with a slope parallel to 3x minus 4 equals y, then all you need is the slope out of this. So you just take the slope and you say, okay, my m is 3. So parallel means that they never touch. They will run the same. They will look like this. And they will run forever and ever side by side and never touch. So for parallel, it makes sense. It makes sense that they are rising and running the same amount every time. Perpendicular, on the other hand, is just the opposite of parallel. It means that they cross one time and they meet at a 90-degree angle. So they're going to look like this. And this is going to make a 90-degree angle. And this is not much more difficult. You just have to know the little trick. And the trick is to take your slope, and instead of just leaving it the same like we would for parallel, you make it a fraction, and then flip the fraction and make it negative. So this is the slope of the perpendicular line. So, for example, number 5. Write the equation of a line. It says parallel, but we're gonna do perpendicular to the line 2x minus 5y equals 10. So there is a way that we can get the slope straight out of this. But to make it simpler for you guys, we're going to work in slope-intercept form. So this is standard form, and you can get the slope out of standard form. But we're going to get it in slope-intercept form just so it looks the same every single time. So to get it in slope-intercept form, we need y by itself. So I'm going to move my y over here, and I'm going to move my 10 over here. So I'm going to add my 5y. So I'm going to have 5y over here, and I'm going to subtract my 10. So now we have almost slope-intercept form. We have to get it completely by itself. So 2/5 x minus 2 equals y. Now we have slope-intercept form. And we have our slope. So I'm going to write my slope up here. And we want a line perpendicular to this one. So we need to get a perpendicular slope. So the process for that is to flip the fraction and make it negative. So our perpendicular slope is going to be 5/2 negative. Now we want the y-intercept of 0, -1. So now we're doing good. We have the slope of what we want, and we have a y-intercept. So we can just go ahead and put this in slope-intercept form because we have a y-intercept and we have a slope, which are the things that we need. So we can do y equals -5/2 x minus 1. And for parallel slope, all you would do is leave the slope the same. Does this make sense? Are we lost?
I would forever be lost with slope.
Sort of lost.
Sort of
Yeah,
lost?
I get it. You break it down.
Okay. The biggest challenge for you guys in this type of thing is going to be knowing what to do. It's not going to be knowing how to do it. You're going to understand how to do this and how to do that. And if I tell you what to do, you're going to say, good, I can do that. But your biggest thing is going to be saying, okay, what do I do given this information?
Somebody raise their hand. My name is Doug.
I'm Jay Duncan.
Oh, no.
Okay, so
I thought somebody was on the thing raising their hand this question. Like somebody that's not in
Okay, so let's work one more and then we'll call it quits for today. So if we have, we want a parallel slope to 2x plus 3, and we want it to pass through 1, 2. So what is the first step that we would do for this problem? That's for perpendicular, not parallel. So what's first step? First step is to pull our slope out.
You said parallel?
Mm-hmm.
Oh, parallel, oh, okay.
You good?
Make sure they oh, no, they had the same Y, they had the same, no, they had the same something, they had the same slope. There you go.
They have the same slope if they are parallel. So we now know more information. We know that our slope needs to be 2 because we just pulled it out of this equation. So now we have a point and we have a slope. Maybe there's a form that we can put these into.
Wait, 1/2 is a rise over run?
No, 1/2 is a point that we want our new line to pass through. I'll write the full problem out. So we want a line thank you.
Even better on paper, but it's right on it.
It is weird on the iPad. Okay. So if we look at this, okay, we have, I like taking and writing all my information in one spot. So I'm going to say, okay, this thing's great sometimes. We have 2x plus 3 equals y, and we have 1, 2. So what we need here, we don't have enough information to put it directly into a form yet. We need a slope.
Did you go ahead and graph that?
You don't need to graph it.
No.
Because all you need is the line parallel to it. You don't need this line. And all parallel means the same slope. So we can take and just pull the slope out of this. So we pull our 2 out. And we know that since parallel means same slope, that we found our slope. So now we use point slope form because we have a point and we have a slope. Y minus y1 equals mx minus x1. And now we can plug our point and our slope directly into point slope form. So when we do that, we do y minus 2 equals 2x minus 1. So now to get it in slope intercept form, we're going to try to get y by itself. So I'm going to do that first by simplifying on the right side and then adding my 2 across. So I'm going to multiply this 2 in. And I'm going to add this 2 across. Y equals 2x plus 1. So now we have a slope that's the same as our original slope, which means that they're parallel. And if we want to check if it passes through this point, we can just graph it.
Wait, if you multiply, why didn't you multiply 2 times 1?
the 2 and the 1 would make.
You're right, I didn't.
So it would be just y equals 2x.
Yep, my bad, guys.
A little confused.
So when this cancels out, we just have y equals 2x, or y equals 2x plus 0 for slope-intercept form. So when we go to graph this, we're trying to see if it passes through the point that we need it to pass through. We know that the slope's the same, so we know we're good on that point. So we put a dot at 0 because that's our y-intercept, and then we do our up 2 over 1 because it's 2 over 1. We put a dot there, and we make a line.
Where did you get the over one from? Oh, never mind, because it has to go.
It has to be a fraction. So if we look and we look for 1, 2, we go over 1, up 2. We have actually passed through the point that we need to as well. So we are good to go on that. All right, so I'm going to let you guys go today, and y'all have a good day.
I like how you think you got a lot of good. That's fun.
Mm.
We